everyone, good morning. Today is March 1st. So today we will finish section 2.5 and we will start 2.6. I just print out the 2.6 handouts. Okay, let's see. Is Dylan here? Dylan? No, oh, I still have, yeah, it's exam. Okay. All right. So let's continue. Last time we talked about 2.5, right? Okay, let's review. What's the graph of the function look like? So hands up, everybody. Line, x squared, x cubed, x cubed. Yeah, one hand up, one hand down, and then square root, cube root, like that, right? Absolute value, Ishan, and reciprocal, 100, like that, right? like that, okay, reciprocal. And then last time we talked about given the absolute value, right? If we add 2 to the entire function, this is changing the y. Okay, everybody? So changing the y, that we either move up or move down. And so last time we know that if we change the y to y plus 2, so you're adding the entire function by 2, then our graph should up 2 units, right? And if we subtract 2 for the entire function, we are changing the y, then we shift down 2 units. Do you remember that, everybody? So this is changing the y. And if we multiply the whole thing by 2, so this is still changing the y, okay? If you multiply the whole thing by 2, then the effect is we have vertical stretch. Okay, so vertical stretch by a factor of 2. If you multiply the whole thing by a fraction, which is less than 1, then you get compressed. But you can say vertical stretch by a factor of 1/2, or you can say compressed by a factor of 2. Okay, everybody? Do you remember that? But here we are changing the y. Okay. So vertical compression stretch is changing the y. And then this one, do you see we add 2, but it's add 2 of the x. Do you see we're changing the x? Yes? Okay, let me ask you. So let's say this is the parent function. And we look at x squared plus 1 plus 2. And then we look at parentheses x plus 2 squared. So here, we're changing the x or changing the y. Why? Because you add the whole thing by 2. Right, everybody? So here, we're changing the y. So you can put x, y, and how do we change? We add 2 to the y. Okay, so x is the same. We're changing the y. So y becomes y plus 2. Okay, how about here? We're changing the x. Yes, everybody? So we're changing the x. Therefore, the point x, y, the x now is become x plus 2. But the y remain the same. You see our y coordinate, the outputs remain the same, but we're changing the input x. Yes, everybody? And if we're changing the y, add the number, shift up. Okay, that's vertical shift for if we're changing the y. Subtract the number, shift down. But for x, it's horizontal shifts. And what is the rule? If you have positive, shift left. Okay? If you have negative, shift right. Okay, everybody? So this one you gotta remember. Left, plus left, negative, right. Okay, so remember that. And then here, what if we have a minus sign in front of x or in front of the whole thing? Look at this. This is square root of x. This minus sign is in front of x, right? So we are changing the x or y. We're changing the x or y. The negative sign is in front of the x. So we're changing the negative sign. So look at what's the difference? Here the negative sign is just in front of the x. But here the negative sign is in front of the whole thing. So then this is changing the x. In front of the whole thing is changing the y. Yes, everybody? Now you see the difference. Ooh, let's put it down here. Y equals, okay, so yeah, x, then y equals square root of negative x. Here we're changing the x. So we put minus sign in front of the x. And then here, if you have minus sign in front of the whole thing, see this is the whole thing, then we're changing the y. So far so good? Yeah? Okay, and when you change your x, what happens? If you put a minus sign in front of the x, then you have x changed to minus x. But your y remains the same, right? You know that, let's say, okay, I have a point here, it's xy. Negative x means it's the mirror image across the y-axis. Can you see that from the picture? Oh, then you get, oh, I get a reflection over the y-axis. Sometimes I don't memorize this. I draw the picture. Every time you draw the picture, think about, okay, my x becomes minus x. What do you do to it? Is mirror image about the y-axis. Okay? And then how about you change the y? Okay, if you put a minus sign in front of the y, well, change the y. You know, y is here, but negative y is below the x-axis. Can you see that, everybody? So therefore, this is reflection over the x-axis. Okay. So those are all the transformations. So we gather all of them together. So this is the transformation. We have horizontal shifts and oh, I forgot the line. Or is it here? Oh yes, it's here. Okay. Yes. So this is the table, and we have okay. Horizontal shift is when we change the x, and the y remain constant. Okay, so plus is left. Okay. Draw it. Yes, plus is left, and minus is the right. Reflection. Oh, okay. All right. So attendance sheet. Okay, and let's see. All right. Okay. So everybody has the weekly chat list sheet? Yes? Okay. So I haven't seen many of you come to see me yet this week, but I want to make sure you do see me. So we started initial here, and then I'm available tomorrow from 10 to 2 p.m. and from 3:20 to 5 p.m. A lot of time. Okay. And on Friday, I'm available from 1 to 2 p.m. and 4 to 5 p.m. So put down your name, put down your phone number, put down what time you're gonna come to see me. You know my office, Snyder 159. Last time I said, I'm your mommy. I'm gonna hold your hand and really push you. Okay, let's try our best to pass this course. So yes, so check the weekly chat list. Did you do your homework? Did you read the notes, and did you schedule an appointment with a tutor and go over those practice problems? Math is really a little practice. It's like you're advocating, right? So you do a lot of practice so you can do well on the team, right? So math is like that. You do a lot of exercise, your body get used to it. Mm-hmm. Okay, yes. Thank you. And it wouldn't take long, probably just 10 to 20 minutes. It depends on how many questions you have. So I just want to check on you. So bring your notes, bring your homework, bring your questions, bring your practice exams. So I know some of you haven't turned in your practice exams. You can still turn those in and receive 10 points. Okay, remember you use pencil to finish your work, and then you put the solution. Use red pen if you're correct. Take a check mark. If you have mistake, pause it and write a correction next to it. And estimate your score. Okay, everybody? And exam correction and record. So you have your exam back. Which problem you have mistakes? Write down the correction next to it. Do you know where the exam solution is? Yes, it's on the website at the bottom, below the practice exam. And exam wrapper is like an exam survey. It asks you how did you study and what mistakes did you make and how I can help you to not making that you Okay, exam correction is 5 points. Exam wrapper is 5 points. Okay, so let's try our best. Okay, so and then reflection. Yeah, we talk about reflection. If the minus sign is in front of the x, then we're moving the point from here to there. So reflection over the y axis. And if the minus sign is in front of the whole thing, we're like changing the y. Then changing the y is from top to bottom, right? So it's reflection about the x axis. So that's reflection, vertical stretch, and compression. If you multiply the whole thing by c and c is greater than 1, then we have vertical stretch. If you multiply by 1 over c by the whole thing, then we have compression. Okay. And if you add the whole thing by c, move up. Okay. Subtract by c, move down. So vertical shift. Okay, we can combine any combinations of these transformations to any given function. To graph a transformed functions, it is a good idea to plot key points of the basic function and then move the points based on the transformation. And please follow this order. Okay? Why? Because if you use a different order, your transformation might be different. Okay, so please stick with this order. First one, shift left or right. What shift left or right means you're changing the x or changing the y. Which one? Are you changing the x or changing the y? Left or right. So if you change the y, it's up and down. So yes, changing the x. So okay, let me put it down. X, y, go to x, and y remain constant. And plus is left, minus is the right. Okay, that's the first step. You check whether you have changed of the x. And then reflection about the y-axis. Reflection about the y-axis. That means we're changing the x. Remember your x here, and then minus x there, right? Okay. And then reflection about the x-axis. See, about the x-axis, then we have what? We're changing the y. Yes. And vertical stretch or compression. That means we are changing the y. We multiply it by a constant c. Why do we put them in the same step? Because your c could be positive, your c could be negative. So if c is negative, you can like break it into 2 smaller steps, right? You like reflect about the x-axis and then stretch. Okay, so it depends on C, whether C is positive or negative. Okay, so that's why we can put them together.
What does the C?
C, any number, like 2 or 5, any, primary, any constant, right? Shift up or down, we're changing the X or Y. The Y, right? So X, Y, and we get X, Y plus or minus C. And plus is up, minus is down. Okay? Are you in?
Yeah.
Okay, so I get your exam and the weekly checklist. Have you been watching the video?
Yeah.
Yes. Okay, so yeah, the sign-in sheet, put your name, like what time do you want to see? Yeah.
All right, thank you.
You're welcome. Okay, yes, those are the 4 transformations. We must follow this order, okay? If you don't follow this order, the transformation might change. So, for example, if you stick with this order, wow, then you get shift left in the first step. But if we change the order, maybe you get, instead of shifting to the left, you get shift to the right. So it will change. Therefore, please follow this order. Okay, now I want to work on less examples but harder examples. So let's change this problem. Okay, let's change to negative 2 square root of x minus 1 plus 3. Okay, so let's change to this problem. Okay, yes. So we agree to go over examples slower, which means less examples. Okay, let's do harder examples because in exam you do harder. Okay, so you always start with the parent function. The parent function are line, parabola, x squared, x cubed, square roots, cube roots, and what's that? Extra values. Those are the parent functions. And also remember the key points. So what are the key points? In session 2. Where's 2.3? Oh, wait, 2.4. Yeah, right here. So we have the library of the parent functions. Okay. And also remember those key points. Line, you need just any point will work, right? Just 2 points you can fix the line. But for parabola, x squared, the key points are 0, 0, 1, 1, 2, 4. Minus 1, 1, minus 2, 4. So we have 5 key points for parabola. Okay, everybody, so you just connect those 5 points together. X cubed, 5 key points. You see, 0, 0, 1, 1, and then 2 cubed is 8, right? And then minus 1, minus 1, minus 2 cubed is minus 8. We also have 5 key points for x cubed. Right, everybody? Can you see that? And square roots. What are the key points? How many key points? 3. They are 0, 0, 1, 1, and 4, 2. Okay? We call integer points. That's why we don't plug in square root of 2. That's not integer. Square root of 3 is not integer. Square root of 4 is an integer. That is 2, right? So we look at those 3 points. And then key roots. How many key points? 5. They are 0, 0, 1, 1, 8, 2. Do you see so later on, when we talk about inverse function, you see this guy and this guy, they're kind of similar. It's like you flip this graph across the line y equals x. So that's why it's like changing the x and y. So this point is 2, 8. Now this point is 8, 2. So you switch the x and y. So we will talk about inverse function later, and we'll talk about that more. And absolute value, how many key points? 3. There's 0, 0, 1, 1, and minus 1, 1. Okay? So when we do the transformations, please remember the shape. Also remember the key points. If you don't remember, it's okay. Always draw a table, plug in your x values, then you get the y values. Okay? Yeah. So this is how we get it. Now, always start with the parent function. So our parent function, y equals square root of x. What are the key points? What's the shape? Everybody move your hand. What's the shape of square root? Yeah, like that. And it passed through the 0, 0, right? And the next one is next point, when you plug in x is 1, what's square root of 1? 1. And what's next point? 4, 2, right? And we connect them. So this is the parent function. This is the graph of it. And we have 3 key points. That is the first step. Okay, everybody? So yeah, first step, we draw the graph. And in this case, we have 3 key points. It depends on the function. Some function might have 5 key points, but this one we have 3 key points. Okay, now we check. Go down the list. Do we have shift left or right? Look at your x. Okay, parent function, we only have x by itself in the square root. This is our target function. Do you see inside the square root we have x minus 1? Yes, you see x minus 1? So the minus 1 is changing the x. Okay, it's next to the x, it's not. You see the difference. The x3 is you add the whole thing by 3. So that is changing the y. But the minus 1 is next to the x. So we're changing the x. So first step, shift left or right. Do you change your x by add or subtract a number? Yes. So therefore, the first step we change the x. And we change the x to x minus 1. Okay? You write down every step, you write down the formula. Okay? So you start with the parent function. Now we change the x. Replace x by x minus 1. Write down the formula. And what transformation? This is shift left or right? Yes. So shift right 1 unit. Is that okay, everybody? Yes, we shift right 1 unit because plus is left, minus is right. Okay, that means, look at your key points. Shift right 1 unit. So this point was 0, 0. Now you move. It become what? It shift right. So it become 1, 0. Yes, everybody? Look at this point. It was 1, 1. You shift right 1 unit. What happened? 2, 1. See, you are changing the x, but the y remain constant. Yes, everybody? How about you guys take turns to answer my question? How about we start with this side? Let's pass this down. Here, Helen. What happened to this point? If we shift to the right, it becomes a x?
Oh, 5.
Yes. 5, 2. Yeah, we shift to the right, we get 5, 2. And then we connect them. And you see, is the whole graph, we shift to the right 1 unit. Yes, everybody? Okay. Then we go down the list. Nice. Do we have reflection about the y-axis? So we go down the list. Shift to the right. We have that. Next one. Do we have reflection about the y-axis? What does that mean? Do you see a minus sign in front of x? Do you see a minus sign in front of x? No. You see everybody? So no, we don't have reflection about the y-axis. Then we go to the next. How about reflection about the x-axis? Do you see a minus sign in front of the whole thing? Yes. So the next picture. Put a minus sign in front of the whole thing. Okay. So we're doing step by step. Okay. Here, look at the previous step. It's like that. And then we add a minus sign in front of the whole thing here. Okay, everybody? And so this is reflection about the x-axis. So reflect about the x-axis. The reflection like mirror image. Hey students, hurrah! Look at this point. If we reflect over the x-axis, what happens? It stays there. So we still have 1, 0. Can you also tell me this point? If we reflect over the x-axis, what happens? Is this point, right? And it is, what's the coordinate? 2, -1. Yes. So 2, -1. Okay, next student. Caleb, what happened to this one? Yes, 5, -2. Yeah, 5, -2. And then we connect them together. So my suggestion, put the little arrow to indicate what you are doing. Okay? Then connect the points smoothly. Any questions so far? So we go down the list. Okay. We did reflection about the x-axis. Do we have vertical stretch or compression? Do you have a number multiplied by the whole thing? Yes. Do you see the 2? Okay, so we have this. Right? The next step. Do you have a number multiplied by the whole thing? Yes, that's the 2. So, okay. So, yeah, I kind of combine example 5 and 6 to make a more complicated example. So, let's continue. Okay, so here what we're doing, we multiply the whole thing by 2. Okay, then because 2 is bigger than 1, we have vertical stretch, not compression. Is that okay, everybody? If I give you 1/2, then it will be compression. Yes. So here we say vertical stretch by a factor of 2. So this is what you're going to do it on the exam. You have a lot of this picture. So each step, you draw the graph, write on the formula, and write on the transformations. And you must stick with that order. Okay, everybody? So now, let me shrink it a little bit. Look at the points. How will the point change? So here what we're doing. So sometimes if you want to put more notes, right here, we are changing the y. What happened with the x? Stay the same. A typical mistake is students multiply the x by 2 and multiply the y by 2. No. X is the same. Y multiplied by 2. Look at this point. 1, 0. Even. Yeah. This is 1, 0.
Yes.
Right? If we stretch, multiply the y by 2, what happens?
Be the same.
Yes, be the same. Okay? So 1, 0. The x coordinate is still 1. The y coordinate is 0. 0 times 2 is still 0. Right, everybody? Okay, Peter. Look at this point. This point is what? Yeah, and then when you stretch, what happens? Do we change the x? Yeah. Do we change the x? Yeah, we're changing the y. So, yes, we're changing the y. So this point becomes 2,
-2.
A typical mistake. Didn't multiply the x and y by 2. No. Keep the x be the same. Only change the y. Okay, David, can you tell me what this point is?
That's 5 negative 2.
Yes, it is 5 -2. And then what do you do to it? And then the new point is?
It would be 5 negative 4.
Yeah, very good. So this is the new point. 5 -4 right here. And then we connect them smoothly. Let me draw better. Okay, so connect them smoothly.
This is the graph. Okay? So I would say this steps, usually students make mistakes on the steps. Our recommendation is write down the coordinates for the points. And then you clear, okay, am I changing the x? Am I changing the y? To confirm. Okay. Good.
So continue, right? And so we have
The third one, check. Right? We have refraction about the x-axis, and then we have a vertical stretch. Last one. Do we have shift up or down? Do you have the whole thing add or subtract a number? Yeah. So if the whole thing add or subtract a number, we are changing the y. So we shift up or down. If it's positive, then up. Yes, up 3.
okay. Now, how would the formula change? So see, the formula is like the previous step, and now we
Add 3 to it. Right, everybody?
and the transformation is we shift up 3 units.
Okay. Yeah, do you? Look at this point. If you shift up 3 units, what's the new point?
It's going to be 3 over.
What's the x coordinate?
The x coordinate is 1.
And then the y coordinate is?
So 1, 3.
Yes, 1, 3.
Right. Okay, so we move up here, 1, 3.
Okay, Alice. How about the next point if you move up 3 units? The next point, when you move up 3 units, what do you get? Yes. So what's the x coordinate? 2. Yes.
So 2, 1. Okay, so 2, 1 right here.
Last one. This point, if we move up 3 units, what do we get?
Yeah, we get 5 -1s. So 5 -1 right here. Connect them smoothly.
Okay. Then we finish the problem. So this is the graph of y equals -2 square root of x minus 1 plus 3. So you go down the list. Make sure you have that order because if you switch them, maybe instead of
Shifting to the left.
instead of shifting to the right, you might have shifted to the left. Okay, so if you change the order, the transformation will change. So the order is very, very important. Okay, read with me. 1, shift left or right. Read with me. 1, shift left or right. 2, reflect above the y-axis. Move your mouth. 3, reflect above the x-axis and vertical stretch or compression. 4, shift up and down. Read it again. Now, 1, shift left. 2, reflect above the y-axis. 3, shift over down. Yes. So don't be shy. Really, really. You know, English is not my first language, so sometimes I say something wrong. I do apologize for that. Because sometimes my brain just translates it in English. And sometimes I say it too fast that makes me sick. It's okay. Don't be shy.
All right. Okay, good. So now,
Look at this example. Okay. So the parent function, f of x. Go down the list. What was the first one? Shift left or right. How can we tell? Do you have an x add or subtract a number? Yes. And this is subtract 1, right? Anybody?
so, okay, let's not draw the graph first. Let's figure out all the transformations. So the first step, okay? First step, we shift left or right. Yeah, left, right. And this is right because it's minus. Okay, so we shift right 1 unit.
Is that okay, everybody? That one. And then, what was that two?
Yes. Refer about the y-axis.
And when you check it, do you have minus sign in front of x? Yes. See, we have minus sign in front of x.
So you put what? Minus sign in front of x. And this is reflect over the y-axis. Okay? What's the next step? Yeah, reflect about x-axis and what? Yeah, vertical stretch or compression. Okay.
Do you have reflection about the x-axis? What do you want to check? Do you have a minus sign in front of the whole thing? Yes. So yeah, we do have that.
So yeah, we have that, we have that, we have that. Okay. Now you change it to minus sign in front of the whole thing. But when you change, make sure you're changing the previous step.
Okay. So you don't put minus f of x. You put minus of your previous step. Is that clear, everybody? Okay.
And this is refraction about the x-axis.
Do we have vertical stretch? Do you have this guy multiply a number? Do you have this guy multiplied by a number? No, right? We don't have multiplied by a number.
Therefore, we do not have vertical stretch. No vertical stretch. How about the last one? Shift up or down.
And yes, down by
2. So we get negative f of negative x minus 1 down 2. So shift down 2 units.
okay. So by just looking at the formula, go down the list, check it one by one, and then make sure you write down all the steps. So in the exam, if this problem has 10 points, and each step you have 2 points. Missing the graph, you lose 1 point. Missing the formula, you lose 1 point. Missing the translation, you lose 1 point. Is that clear, everybody? Okay. Now, let's draw it. Here, how many key points?
4. So they are, wait, what's the coordinate of this point?
-4, 0. Okay.
And how about the next point? -3, -1. Next point. 0, 2. Next point. Yeah, 3, 2. Okay, good. We should write 1 unit. This becomes. Hey, how about you guys practice that? Yes, yes. Write it down on your paper. And okie dokie, when shift off, that was to the right 1 unit. What do you get? Oh,
Yeah, I'm trying to, yeah, no, I'm trying to get it here.
oh. It's a good habit to mark the coordinates. Because your coordinate, make sure your x-step is equal to x, is equal to y. Yes, it's a good habit to write down the coordinates. Oh, it can be erased. Interesting. Good. Yeah, keep going. Uh-huh. Yeah, keep going, keep going. So, yeah, keep going until you finish the whole round. So we start over x-axis. What do you do? Reflect about the x-axis. What do you do? And shift down to unit. How is that?
Oh, you will write.
Yeah.
You say translation means like one.
Yes, every step you write on the translation, write on the formula, and write on the graph. If you miss one of them, you lose.
So right.
Yeah. Over the y-axis, y-axis. Jump it over here. Like the mirror. What's this? What's this? Oh, C, this emergency is positive number. So when you add C, your Y is bigger. Your Y is bigger. Y is more positive. Yeah, it's not C because then your Y is bigger. Look at your Y-axis. The bigger value is the top. And the more negative numbers is the bottom. So therefore, if you add a number, your Y is bigger. Bigger is moved up. If your Y subtract the number, is smaller. Smaller. Yeah, that's it. I don't have it.
Okay, sorry.
Yeah, you can print it out. You know, let's say, take notes. Oh, by the way, if your exam score is over 70, you don't have to do anything. If you're lower than 70, you have to do that. And in the next exam, if you get your score more than 70, then you don't need to do. Okay, so yeah, we keep track on you. Oh, okay. So this is like the mirror, right? Then for this point, mirror image. So it's like you look at okay, 1, 2, 3, 4. So you look at here, 1, 2, 3, 4. A 5, 4, 4, 6. Okay. And then here, you go to the right 1 unit. Now you go to the left 1 unit. Sorry, like a mirror. And the same thing here. It's like this is a mirror. It's like a mirror. Okay.
So let's check our work. Okay, 2.5. Okay. All right.
So this is what we have, right? Then, I think I have mistake. Because we fractions over the y-axis should be like that. You see, sometimes I make mistake too. You see that, everybody?
Okay, so that was my mistake. Then we should do, okay, so we already have shift right. Like this point is here, 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 and here. Do you all get this right? And then you flip it over. So this point here, and then here and here. Connect them together. And reflect about the x-axis. So this point stay here, and the x-axis is like the mirror. Now you have this point, and then this point go down here, this point go down here. So, and we connect them, right, everybody? And then we move down 2 units. So this point move down 2 units right here. This point move down 2 units here. This point move down 2 units here, and this point move down 2 units here. So do you get this picture? Yes? Okay. So this session is hard because it includes a lot. With the transformation, you have to stick with that order. So I really hope that you can do more practice. So here you have practice. So please work on your work with your tutor or exercise, and then come to see me and ask me if you have questions.
And also on the website, do you see
The grid, okay? So this is the grid. If you want to print it out and draw it, you can use the grid. And this is a practice problem. Your next quiz like that. Your next quiz looks like that. Okay, so this is a practice problem. So do it for this problem, and you have an answer as well. Okay, so promise me you're gonna do that practice problem. Promise your quiz is gonna be like that. All right. Have a nice day. Thank you.
Oh, the fraction about the x-axis, then you put a minus sign in front of the whole thing.
So from the y-axis,
From the
we
y.
change like the y, right?
We put the x.
So yeah, so the one becomes negative.
Yes, exactly. So you just like here, your x. Oh, sorry. Thank you. Your x. You put the x. The y remain the same.
Okay.
And then here, your x the same. You put the y.
Okay, and like from from shifting like so we use this point to go here.
Yes.
So we don't go back to the original.
Oh, yeah, of course. That's why we use this all the steps. Every step we look at the previous one and then change.
Okay. Okay, thank you.
You're welcome.